Hello, today we will discuss about Ethernet at physical layer. So how Ethernet works at the physical layer of an OSI model. In this we will learn about various Ethernet evolution like standard Ethernet, fast Ethernet, gigabit Ethernet and the 10 gigabit Ethernet. So first let's discuss about the Ethernet at physical layer. So the Ethernet at physical layer defines the electrical or optical properties of the physical connection between a devices and the network. So it tells about the medium of transmission used between the network devices. So its speeds range from 1 megabits per second to 10 gigabits per second. The physical medium can be a coaxial cable, twisted pair cable or a optical fiber. So it means that Ethernet at physical layer defines the transmission medium used by the devices connected in the network to transmit the data over the network. So next is evolution of Ethernet. How Ethernet evolves. The first Ethernet uses standard Ethernet and its speeds ranges from 10 megabits per second. The type of standard Ethernets are 10 base 5, 10 base 2, 10 base G and 10 base F cables. The next evolution is fast Ethernet and its speed is 1000 megabit per 100 megabit per second. So the types of fast Ethernet are 100 base TX, 100 base FX and 10 base T4. The next evolution is gigabit Ethernet having speed of 1 gigabit per second and its types are 1000 base SX, 1000 base LX, 1000 base CX and 1000 base T. And the new evolution is 10 gigabit Ethernet having speed of 10 gigabit per second. So this is a new technology of Ethernet. Let's discuss first about standard Ethernet having the speed of 10 megabit per second and it is using baseband signal to transmit the data. So the first Ethernet is 10 base 5 and it transmits signals over the distance of 500 meter and it can connect many nodes per hub. And the topology used by the 10 base 5 is bus and cable type used by 10 base 5 is thin coaxial cable. The next cable is 10 base 2 and it transmits signal over the distance of 185 meter and it can connect any number of nodes per hub. And the topology used by the 10 base 2 is bus and the cable type is thin coaxial cable. The next is 10 base T. The distance traveled by the signals using 10 base T cable is 100 meter and it can connect 1024 nodes to the hub. And the topology used by 10 base T is hybrid star bus topology and Cat3 category 3 or a UTP cable is used by 10 base T cables. The next is 10 base F. It transmits signals over the distance of 2000 meter and 1024 nodes can be connected to the hub. So the topology used by the 10 base F cables are star bus topology and multi-mode optical fiber is used in 10 base F Ethernet cables. The next is fast Ethernet having the speed of 100 megabit per second and it is also using baseband signals. So the Ethernet cable like 100 base T4 it transmits signals over the distance of 100 meter and it can connect 1024 node per hub and the topology used by the 100 base T4 is star bus and the cable type used by 100 base T4 is category 3. So the 100 base TX it transmits the distance over 100 meter and it can use the cable type like category 5 cable and SGP cable, shielded twisted pair cable and UTP unshielded twisted pair cables. The next is 100 base FX. It transmits signal over 2000 meter and using multi-mode optical fiber cable type. The next is gigabit Ethernet having the speed of 1 gigabit per second and using baseband signal to transmit the data. The first is 1000 base SX. It means short wave fiber. So it travel distance up to 550 meter. So it using bus topology, and cable type is short wave fiber. The next is 1000 base LX is transmit the signal over the distance of 5 kilometer, and using long wave fiber cables to transmit the signals. The next is 1000 base CX. It transmits signals over 25 meter, and the cable type is used by it is copper STB, two pair of cables. The next is 1000 base T. It transmits the signal of 100 meter, and it is using copper unshielded twisted pair, four wires to connect the devices in the network. So to understand standard Ethernet codes, we have to understand the meaning of each code. So 10 at the beginning indicates the speed of network, that is 10 Mbps, and 100 indicate that the speed is 100 Mbps, and 1000 indicate that it has the speed of 1 Gbps. Then is base. The base indicates the type of signaling used, that is it is using the baseband signal to transmit the data. Then is 2 or 5. At the end indicates the maximum length of the cable in meters. Then next is T. T at the end stands for twisted pair cable. X at the end stands for full duplex or cable capable cables. Then is FL. FL at the end stands for fiber optic cables. Same way, like SX stands for the short wave, LX stands for the long wave, and CX stands for the copper cables, and T stands for the UTP cable. Same way, T4 stands for the category 3 cable, TX stands for the category STP and UTP cables, and FX stands for the fiber cables. And here 5 stands for the distance of transmission, 2 also stands for the distance of transmission, T stands for the UTP cables, and F stands for the fiber cable. So same way, these codes have their own meaning, and we have to understand these codes so that we can lay the effective Ethernet cable in the network. So this is all about Ethernet at physical layer. Thank you.